Okay, we're asked to find the derivative. This is a new notation, but we're just asked to find the derivative of the square root of x. So we're applying that same definition. Oops, almost forgot my limit there. Okay, so it's the same definition. This question is just asked using a different notation to get you comfortable with using a new notation. Okay, but let's look at this thing. This actually should look pretty familiar in terms of the last exam we just took. So I was trying to get you used to these sorts of actually, let's change color. These sorts of limits, because now we've seen how to deal with these square roots, right? And so we know that the approach we should take here is to multiply by the conjugate, which is going to be to multiply by x plus delta x, the square root of that plus the square root of x, right? We're doing it with a plus sign purposely, so it's the conjugate, which is going to eliminate the square roots in the numerator. What I would love for you to do right now is to pause this video and actually expand out that numerator and look at the denominator. So think about this like it would have been on the previous exam and try to work through it. Okay, hopefully you did pause it and work it through on yourself. You're going to feel more confident if you can do this on your own. So in the numerator, when we FOIL, the square root of something times itself just gives you the inside of that square root, right? So x plus delta x. The outers and the inners have opposite signs, so they cancel. And then minus the last is just going to be minus x, okay? And in the denominator, we're going to leave it in factored form because in a second it's going to help us cancel something. So first of all, let's notice that x minus x is gone, right? So this, again, should feel really similar to a problem that was on the last exam. So we're left with just delta x over delta x times x plus delta x plus the square root of x. I don't know if I read that correctly, but I wrote it correctly. And at this moment here, we can cancel the delta x's, but only because we're continuing to write this tedious expression, the limit as delta x goes to 0. We're left with a 1 in the numerator, so don't lose that fraction bar, and just the square root of x plus delta x plus the square root of x in the denominator. Okay, now as delta x goes to 0, so I'm going to actually apply this limit. I'm not going to keep writing the limit, right, because I'm actually doing direct substitution right now, and I'm left with 1 over square root of x plus square root of x, or better written as 1 over 2 times square root of x. Okay, so dy dx, our derivative function, is 1 over 2 square root of x. Now we found dy dx, we're done with that, so yay. But now we're asked to find the slope of the graph at some points. So we're going to use this slope function to find the slope at several points. So let's use our new notation. So dy dx at the point when x equals 1 would be 1 over 2 times the square root of 1. So it's going to have a slope of 1/2. Okay, let's look at the function. Right? If I look at this point at the slope 1, that's a reasonable slope, a slope of 1/2. So that makes sense. If I wanted to actually graph the line on Desmos, I'd have to find, so let me scroll back up. I don't know why I just went down, sorry. This is our m, and we're passing through the point 1, 1. So using point slope form would be y minus 1 equals 1/2 times x minus 1. So let's type that in. So y minus 1 equals 1/2 times x minus 1. And there we see that that does in fact look tangent to the curve. So that's good. Now let's go back. I don't know why this keeps scrolling down. Now let's look at the slope at the point 4, 2. My screen's getting kind of crowded here. Need some space. Okay, so let's find dy dx at the point when x equals 4. So I'm using it like a little subscript, x equals 4. So that's going to be 1 over 2 times, remember, the square root of x, so square root of 4 here. So that's 1 over 4, 1/4. And the equation for that line would be y minus the y coordinate equals the slope times x minus the x coordinate. So let's graph that. Y minus 2 equals 1/4 x minus 4. And sure enough, that does look like it is tangent to the curve at the line, at the point 4, 2. Okay, one more place we're supposed to consider what's happening, discuss the behavior of the function f of x at 0, 0. Well, if we don't think too hard about it and we just try to apply the definition dy dx at x equals 0, we're going to easily see here that something bad happens because we're trying to divide by 0. This is undefined. This is really bad. I'm just scribbling all over stuff here. Okay, so this is undefined. Let's look at the graph and see why that actually is reasonable. If I try to look at the slope, so actually it would be the line x equals 0, right? This has an undefined slope. Tangent to the curve right here would be a vertical line, and of course a vertical line has an undefined slope. So this is a reasonable answer, and so we can see the behavior of f at these various points by looking at the derivative.